Alright, using the Super Bowl halftime to make a quick review video for the main equations from this unit. Here they are. First is F equals QE. This is the force when you have a charge in an electric field. So if a charge is in an electric field and you want the force on that charge, this is what you use. You could also find the charge if you knew the force in the electric field. You could also find the electric field if you knew the force and the charge. Next up, if you just have two charges or maybe a collection of charges interacting, you can do force equals K, Q1, Q2 over D squared. Something that many people made as a mistake here is when a charge wasn't given or it was unclear, they just plugged in the charge of an electron. You only use the charge of an electron if the problem tells you that it's a fundamental charge, an elementary charge, a proton, or an electron. Otherwise, you've got to figure out from the problem what the charge is. You can't automatically assume it's an electron unless the problem lets you know that by saying electron, proton, fundamental charge, electric charge. Remember the difference between these two force equations. The top one is when you know the electric field or are looking for it. Second one, when you know two charges or maybe looking for one of the charges. If you are given a charge and asked to find its electric field, you can also reduce these two equations down to electric field equals KQ over D squared. So if you're given a charge and need to find an electric field, or given an electric field from a charge and need to find it. Other equations are ones that deal with potential. Potential energy is charge times potential difference. And remember that once you've found a potential energy, that's the same as any other potential energy. So you can solve for kinetic energy. You can use the change in potential energy to look at how much work was done in a system. But once you found this potential, you can use it anyhow you want. In fact, there was a review problem that I noticed a lot of people having trouble with, where you were given a speed of an electron and then had to figure out the potential that it had to pass through. And the way you do that is by saying KE, find its kinetic energy, go back to PE, and then from PE to potential difference. So this unit, like all others, does not exist by itself. Potential energy, if you find it, can be related to any other potential energy. And if you're given enough information to find kinetic energy, you can find the potential and so forth. So this unit interacts with all the others in the same way that electric force can be used on free body diagrams and for Newton's second law problems. Next up, if you are given voltage and asked to find electric field, you can, if the voltage given is between two parallel plates, easily use this equation. And if you're given a uniform electric field, and that just means where the field lines are all the same distance apart, so the main example is a field between two plates. Given the field between two plates and you need to find the voltage, you just do E times D equals V. Now in these problems, what can be tricky is the distance for this equation here will always be the distance between the two plates. So if we put a charge in the middle, you might be tempted to say, oh, well the distance is just the distance from the charge to the plate. Nope, the distance is the distance between these two plates. Finally, if you're given a point charge and asked to find the potential a certain distance away from the point charge, it's V KQ over D. Finally, something that's given a lot of people trouble, so let's just settle it once and for all. Use the positive or negative sign of a charge to figure out the direction of the force or field only. Do not plug the negative on a negative charge into the equation. So in the equation for force, electric field, your charges you will leave positive, even if they are negative charges. But you will think about, if this is a negative charge, which way would the field lines point? Because remember, field lines would point toward a negative, since they point away the way a positive would go. And field lines would point away from a positive, because they point the way a positive would go. Okay? So use what you know about how field lines point and how forces would go. For example, if I put another positive here, it would get pushed away from the positive, but another positive here would get pulled toward the negative. Use what you know about fields and forces to figure out the direction. Do not include the positive or negative sign in the equation. The only exception, the only equation you should plug positive or negative signs into is voltage of a point charge. It's a scalar, but it does become positive or negative, and you need to know that when adding them together. So this equation, the Q can be positive or negative. In all the others, it would just stay negative. All right, hopefully these tips and tricks help. If you're confused or need help, call me, text me, whatever. The thing I most worry about is people not paying attention to what questions ask. If a question asks for a force, you'll use one of these two equations. If it asks for a field, you'll use the E equals KQ over D squared, or maybe if they gave you the force and the charge, you would use F equals QE. If it asks for a potential, you got to figure out one of the equations with potential in it. Okay? Make sure you have these equations memorized. Also think about how you use each one. Also read every question really carefully to make sure you know what it is asking. That's it. Good luck on Monday.